Okay, hello everyone, and welcome to another webinar presented by Discover the Universe. My name is Julie. I'm the director of Discover the Universe, and I will be introducing our speaker in a minute. This webinar is actually presented by Calvin Schmidt, and he works for the Friends of the Dominion Astrophysical Observatory in Victoria. And I'm pretty excited to have them present today and collaborate with them because I worked for many years in Victoria at the observatory, so it's close to home in my mind. Okay, so before we get started, in case some of you are new, I just want to give a quick intro to Discover the Universe and what it is and what we do. So our goal is to help teachers and educators across Canada and in both English and French by providing free and online educational resources and training in astronomy. We've been doing it actually for almost 10 years now. And so we were doing online stuff long before the pandemic. When we still do it, we sometimes offered in-person training, but not this year, obviously. And so you can browse our website. Everything is free. You can see different training there, different workshops and resources. And we're working in the background on many new ones as well. And I just want to thank our main sponsors, the Dunlap Institute at the University of Toronto, our main supporter, as well as astrophysicists from across Canada and different places. And also we get funding from other organizations and foundations. So this is what allows us to do this all for free. Our next workshop is coming up in April. So after this webinar, actually, the next one will be in April, our workshop for teachers level 2. This is especially made for you if you are teaching around grade 9. I think in most provinces, astronomy is taught in grade 9. So this is meant for you. You can go online, you can register already. And the way it's going to work is it's over 3 weeks. Each week you get access to new videos, new content, things you can try on your own, learn at your own pace. And there's no final exam if you don't have time to do everything. But we hope you join us for it. We will have the level 1, which is meant mostly for grade 6 or elementary school level in the fall. But even if you don't teach grade 9 astronomy, if you are interested, if you think this one would be relevant for you, for your knowledge, for your any education that you're doing, feel free to register as well. And I'm guessing you know where to find us, but feel free to contact us, interact with us on social media, email us if you have questions. But of course, if you're here, it's probably because you went to our website and registered for this specific webinar. If you have questions during the webinar, you can ask them in the chat. That's where we'll be taking questions. I see that the Q&A is activated. For some reason, I didn't plan on having it, but please use the chat. That makes it easier. And if you want to introduce yourself, tell us where you're from. That's always interesting for us to see. I see your names, but I don't know where you're located. So that's always interesting for us to see that. It is being recorded. So if you missed a part, want to see it again, you can come back to our website and I'll be sending that as well to everyone who registered. So I will stop this screen sharing and I will invite our speaker, Calvin, to come and talk to everyone. Hello, Calvin.
Hello. Hello, everyone.
How are things in Victoria today? I guess it's still daytime for you. It's evening.
It is still daytime here. It's just fine. Decent weather. After a cold spell, we got back into what starts feeling like it's going to be spring.
Sounds good. So thanks a lot for accepting the invitation to come and show the resource you want to show today. So there's a specific resource, like we're going to be talking about the sky and how we're seeing stars, but you want to highlight as well the new educational guides that you're developing online. So I'll let you take over. I'm going to hide, but I'll be in the background if people have questions and I'll come back at the end. So thanks a lot, Calvin, for presenting.
All right. Yeah. Well, thank you for giving me the opportunity, Julie. As Julie said, my name is Kelvin. I'm from the Friends of the Dominion Astrophysical Observatory, and we've been working hard to make educational content a resource for teaching and learning. I'm going to share my other screen. So hopefully you see a web browser there.
Yes, we do.
Excellent. Thank you for confirming. So this is Exo Explorations. This is the material. The main conceit is that there's in addition to sort of teaching about the planets in the solar system that we all know about, the goal here is to do all of that, but then also include knowledge of exoplanets, which are planets that orbit other stars. But it covers many topics altogether, not just planets. So I'll start by just getting into the one I'd like to talk about, which is called Seeing Stars, and it's about how we see stars and a couple of the nuances with that. Okay, so each unit, this is unit number 3, each unit is a document that has plenty of text and images. And I'll start talking about how we see things in the sky. And then also, while we're doing that, you'll get an idea of how these documents look. So the first question that's really important to ask, how many stars can we see? Of course, that changes with time. For example, during the day, we don't see any stars except for maybe the sun. And that's an excellent question to start with. It's seems like kind of an obvious question to ask. When I do ask students, they often answer with the sun is really bright, and that's mostly correct. But that's not the full story. Basically, sunlight is coming from the sun and it's hitting our Earth, but it has to go through the atmosphere first. And all of that light scatters around and makes the sky glow blue. And then that sky, that atmosphere, is now brighter than most of the stars behind them, so we can't see them. And then so in this document, it also provides an activity to demonstrate that. For this particular activity, it involves a program called Stellarium. So this is something you can download onto your computer, and you can use that. So I'm going to switch over to that and show you about sunlight in the atmosphere. Okay, so we're in Stellarium. You can see it where we're at here. Here's the sun. So it's just starting to go down. And it's blue skies all around, so we don't really see any other stars. But there are options here in Stellarium to turn off the atmosphere. So simply turning it off reveals all of the stars. So the sun is still up, it's still daytime, but the stars are visible because the light is no longer scattering around, making the sky blue. All right, so and then we'll talk about the moonlight can actually do a similar thing. The moon is not nearly as bright as the sun, of course, but it actually does still have a similar effect. And then so there's an activity that goes through that. So in this one, it instructs you to find when the next full moon is, and there's a website here that quickly tells you very easily. This one says March 28th. So I can go into Stellarium and change the time to March 28th. I can change the day to the 28th. And then I can also fast forward time here so that we can go into nighttime, and hopefully we will see the moon come up. And it will be a full moon, so it will be quite bright. I'll also remove some of these other things. Okay, so here's the moon. It's quite bright. I'll zoom in slightly. And we can see some stars. You can notice all of these stars around here. If I do the same thing I did before, which is remove the atmosphere, you can see a few more stars appear. So sunlight is reflecting off the moon, and as a full moon, it's reflecting all of that that whole face of the moon, and doing the same thing. Even though it's nighttime, it's scattering that light around, making the sky glow a little bit. So at the end of some of these sections, we include links to references and ideas for continuing these ideas and these topics. And we also provide some discussion questions and review questions that are more often open-ended questions that just get you thinking about the ideas that we cover. But I will move on. So another thing that affects how we can see the stars is our eyeballs themselves. So we have holes in our eyes that let light in, the pupils of our eyes, and you'll probably know that when you're in a dark place, your pupils actually get bigger, and so that they can try to let in more of what little light there is in the darkness. And if you're out in a sunny day, they get much smaller, so that they let in less light to not damage your eyes. So the size of your pupil determines how much light gets let in, and that allows fainter things to possibly be seen as the pupil of your eye is letting in more light in the darkness. An interesting kind of note is that it's more like the blue and the green light that causes that change of our iris, the constricting of it. Whereas like red light doesn't really affect that too much, which is why a lot of astronomers that take their telescopes outside into a field to use it to help them set up their telescope, they'll actually use red flashlights often. That way it helps them see things, but it doesn't make their pupils get small, so that when they do go to observe things, it makes it harder for them to see. So the red light lets them see without ruining their dark vision. So yeah, we also provide interesting diagrams and stuff. You can see the pupil of an eyeball being different sizes. Here's another really important cause of us to see more stars in some areas and see less in others. And that's mostly city lights, or really any lights that are spilling out into the sky. It works just like the sun and just like the moon. The light spreads around and scatters and kind of makes the sky look like it's glowing a bit. And that makes it harder to be able to see the stars. So in a very densely populated place in a big city, there's usually it follows that there's a lot of light. So that makes it so that you only maybe see a few stars. I think I've got some pictures here from Victoria, BC. This is not a very big city, but it is still a city if you're downtown. And you can notice in this image that you can see some stars. And actually right here, maybe it's a little hard to see. I wonder if I can zoom in just a bit. You can make out a shape, and noticeable shape, which is the Big Dipper. And then there's a few other of the brightest stars. So in a city, you typically only see the most bright stars. And if you go out into the countryside where there's fewer lights, might be able to see stars like this. So you can see the Big Dipper here being the brightest stars, the most noticeable among some others. And then some of the less bright stars are more noticeable now. So just like with the other ones, we can do this in Stellarium as well. So I'll make sure that the atmosphere is on, and we are looking away from the moon. And I can adjust the light pollution settings. So I'll open this menu, and then we will change some numbers. You can see a number here. if I make this number 9 the largest setting, this will be like in a very busy, dense city with lots of lights. You can maybe see the brightest stars, like Sirius is like one of the brightest stars in the sky, and a couple others. But of course, I can dial it down to like 2 or even 1, and you can clearly see way more stars. And we can also do more than just changing some number which doesn't have much connection to you, but we can change locations and get an idea of what the light pollution is in certain places. One of them that we do in exo explorations is we give the example of Winnipeg. So you can see we've traveled to Winnipeg now. And I make sure that I check this box. So this is the light pollution number for Winnipeg. And this is what the sky might look like. Just barely a few stars, and even less if you're looking at the full moon, of course. You can go to a place, the other example we give is Salmon Arm. And then we can take a look at that. You can see quite a few more stars. And let's see what number that gives us. That's more like light pollution 5. So we can even see what this is here, Orion's belt. Okay, now we're getting into some interesting ideas here, because what we talked about was that, what we talked about was how certain things affect our ability to see stars, like light pollution and light scattering around and stuff. And then the other thing we talked about was our own eyes. When we said that bigger pupils will let in more light. An interesting fact is that owls have even bigger pupils than humans do. So that would mean that they can see more stars, right? This is really interesting. So typically owls can see something like this, we suppose. And this image can also be created in Stellarium as well. I can show that. But there's so many more stars now, you can't actually see the Big Dipper. The Big Dipper is still here. It's these stars here. But they're just combined with so many other stars you can barely notice. And I think I have time that I can show that really quickly. There we go. Okay. So if I go here and I make this like, say, here, we can see plenty of stars. But then I adjust this absolute scale thing, and this is one of the activities. You just make that number really big, and then way more stars show up. And that kind of gives us an example of what owls can do. So if certain animals can see much better than we can, surely we can sort of copy that idea, right? And make really, really big eyeballs. And that is the idea behind telescopes. We use technology to help us see. Okay, so yeah, this is the section where we talk about making our eyes bigger using telescopes. The first telescope to be used for astronomy to look up at the sky was by Galileo Galilei. And so that telescope had a lens that were a few inches in size, and that could collect 28 more times more light than the human eye can. That has to do with how much light it can take in, the area of it. So that's like having a much, much bigger eyeball than even an owl. So that's how Galileo was able to start to see Jupiter, not just in decent detail, but also the moons around it. And then later, we've made bigger and bigger telescopes because bigger and bigger eyeballs allow us to see much more. So The Plaskett telescope in Victoria, BC was built in 1918. So this has 66,000 times more light collecting power than the human eye. So much bigger improvement. So that's able to look at galaxies very far away, among other things. There's also not built yet is the 30-meter telescope, which has a mirror or an eyeball the size of 30 meters. That will be 18 million times as much light collecting power, which will be a whole new revolutionary thing. So here is the mirror of the Plaskett telescope, the 1.8 meter diameter mirror. So this is when it was being built, polished by a lens crafter. So they have to polish it into a certain shape so that the mirror doesn't just reflect back like a flat mirror that you're normally used to, like in a bathroom or something. It needs to not just reflect the light, but also focus it down. So that will be a very, very precise curve, concave shape. And this is the 30-meter telescope. Instead of being one giant piece of glass like in the previous one, it's made up of several segments, and each one is about a meter or two in size. And then so there's like I think over 100 of them all honeycombed around to make one big mirror. So this picture, of course, is just the 3D computer model because it hasn't been completely constructed yet. So we're already getting much bigger telescopes. Okay, here's another important question to answer is why some stars are visible to us and others are not. When you do look up in the sky or using stellarium, your pretend sky, some stars are noticeably bright and others are not. They're not all the same brightness. So one of the reasons for that is because the stars are at different distances. So when light is coming from a star, I'll show a diagram here. So here's like a star or a sun. There's light shooting out in all directions. You can see these light rays going all over the place. And as they go out, they get further apart. So that represents the light, there being less light further away because it's actually spreading out. So if you're an eyeball or a person or a telescope here, you will be catching more light rays at one time. You can see there's maybe like 6 light rays here. Whereas if you move further away, there's fewer light rays in total. So there's like maybe 3 here. So you're, if you're further away, then you get less of the light, and then perhaps it's so few that your eyeball can't even detect it at all. Or maybe it's just barely detectable, whereas some are really bright. And of course, the other answer, which we cover in another unit, is that stars themselves can be different brightnesses, just like some light bulbs can have different wattages. But that is a topic for another unit. And then we talk about something that isn't really a star, or at least doesn't really look like a star. And that is the Milky Way. When you look at the Milky Way, it looks like just like a cloud. There's an excellent photograph in here. So it looks like this is the Milky Way here. So you can see plenty of stars all over the place, but among all of these stars is like this path of cloud, some dark and lighter spots. So this looks like something that's different from stars, and indeed there's quite a lot of dust and gas there. But when Galileo looked at it, noticed that this sort of smooth, milky, gas-looking, cloudy-looking thing was actually made up of stars. It's just that they were so far away that they didn't have very much resolution. They weren't resolved, which means you can't distinguish one from the other if they're so far away. They're just kind of, the light that they're emitting kind of blends together. Here's another image of in addition to the dust here, there's plenty of stars, and it looks like all of these stars are really clustered together, like it's like a pile of sand or something. But that's just because they are very, very far away from us. They tend to look very close to each other, but of course that's still quite the distance. Okay, so now we get into the part of this unit where we actually encourage people to go out and explore and find certain things like constellations and recognizable stars. So you can start in Stellarium without having to go outside. And I'll make sure this gets reset to our usual ability to see stars. And we can look around, and I can activate the constellation line. So it just draws lines between certain stars to make constellations. Some of you may be familiar with some. A lot of them are not too commonly familiar, but here's an example of Orion here with Orion's belt. So this program, Stellarium, can help you find the direction and the place in the sky that these constellations are, or at the very least give you an idea of where they might be. So if I just scroll around, and I think I'll let time go by quickly, we can see some coming up here, like here's constellation Lyra, here's constellation Cygnus, and then there's a bunch of other ones. There's Aquila here. And so what's interesting about these constellations, you may be in a place where it's not very dark enough to be able to see most of the stars. In fact, I can try simulating that by turning this number up a bit. It might look something a little like this, where you don't really see the stars from the constellations too well, but there's a bright star in each one of those three constellations. In Cygnus, Aquila, and Lyra, there's Vega here, and then there's Deneb in here, and then there's Altair here. So these stars are easily noticeable, even in a not very dark sky. And so this makes a triangle, a big triangle in the sky. Usually you can find it in the summertime. So that's something you can look out for. I'll just switch back over here. So we also provide examples of looking for other constellations. For example, the Big Dipper. That's actually a good one to take a look at. So I'll go ahead and try to find that in Stellarium. So we can just let time go on. And the Big Dipper is a fairly common, it's actually not called a constellation on its own. It's called an asterism, just a bit of a different name. And it's full of mostly bright stars, so it's very noticeable in the sky. And if we just look around here, we find a constellation called Ursa Major. So this is a constellation called the Big Bear. You can actually bring up some pictures that looks like a bear. But this is a part of the Big Dipper here. So this is the Big Dipper, these 7 stars. And that's the Big Dipper. And what's pretty fascinating, what's kind of nice is that the Big Dipper can also be used to find the Little Dipper. The 2 stars at the end of the Big Dipper actually point to a star that's in the Little Dipper. So that points to this star here, and that's in the Little Dipper. And that star is also pretty interesting because that is the North Star. That always points north. I'm just going to turn the light pollution down a bit. So this star always points north. So you can use the Big Dipper to help you kind of navigate your way if you don't have a compass and it happens to be a clear night out. So if you stay up all night and watch Polaris, like me fast forwarding time here, you can see that it is rotating all around. All the stars are rotating around, but you only see Polaris staying still until the sun comes up. Then you'd have to vacuum up all the atmosphere so that you can continue seeing it. And you can see that it stays in one place while the rest of the sky turns around. Okay, I hope we're not getting too car sick here or space sick. So in addition to showing how you can do that in Stellarium, we also show how you can do that in the sky itself. And we, yeah, here's the pointing to the North Star. And there's the summer triangle. And then we finish off by just mentioning that, like, if you don't want to use Stellarium or you don't have access to it, you can always make basically what is a star map on your own. You can just download a little printout that you can print out and cut up, and you've got yourself what is called a planosphere, but it's basically like a map of the sky that you can find some things there. So there's plenty of activities to do of just like looking for some of the things you learned about in this unit, some familiar stars or constellations, and then finding them in your own backyard and writing them down and comparing what you found to other people. So that is Unit 3. That's Unit 3 of 8. So if I still happen to have time, I'll just quickly mention the other possible units. Do I still have time?
Hi, Calvin. Yes, you do have time. It is 7:05, so 4:05 for you. Yes, so feel free to go ahead. If people have questions, feel free to type them in the chat.
Yes.
Right now I'm seeing a few comments, but it was a great introduction to Stellarium. So if people don't know Stellarium, that was great. But yes, actually, I think in the meantime, you can go ahead and maybe talk about the other ones a little bit.
Excellent. Yeah. I'm never sure exactly how popular and how well known Stellarium is. Sounds like some teachers are very familiar with it, and then sometimes I find that not to be the case. So the activities don't always involve Stellarium. There's plenty of activities that that are just pencil and paper. There's plenty of activities that that are a little bit more crafty that you get the scissors and the glue out for. So there are currently 8 units. I'll actually just show this document just because we create a fun little document that quickly goes over all of the units that we have. So it starts off by talking about just the stars in the sky, which naturally leads into talking about just like the history of astronomy, the ancient astronomy of the time, and what we thought of stars in the past and sort of how that developed. And then we talk about the intrinsic properties of stars in Unit 2. So things like mass and size and temperature and color, very important things for stars. Then we, of course, have Unit 3 on how we actually see the stars. Then we actually get into more detail of the Milky Way in Unit 4. And then we learn that it is not just the universe entirely. It's just one galaxy in an entire universe full of many other galaxies. So Unit 5 covers all the different kinds of galaxies there are and the entire universe as a whole. And then we zoom back in to learning about stars and planets and how solar systems are formed. And then we start to get into where I mentioned that this has to do with exoplanets. We start to compare different kinds of, planets, including exoplanets, all their different properties that they have, kind of like how I mentioned the stars have mass and size. We talk about the mass and size and comparing planets as well as their atmospheres and all the different properties they can have. They're much more varied and interesting. There's plenty to discover, not just in our own solar system. In Unit 8, we finish with comparing different kinds of solar systems. So not just planet to planet, but also how those planets orbit the stars and how many stars are in the solar system, that sort of thing. And we also have something that's kind of unfinished, is just how we learn how to detect exoplanets, planets that are going around other stars. So we actually have a little activity where you can sort of create your own simulation of an exoplanet discovery or detector. And in the future, we'll actually have that fully fleshed out into a whole new unit.
We did get a question from Ed asking if you discussed the life cycle of stars as well.
Oh, yeah, that's an excellent question. We do touch on it in Unit 2, I believe, and also in Unit 6 as well. So it's not an actual full-on topic in a box. We kind of mention it when talking about properties, and then we mention it when talking about how stars are formed and they're born. So you get that through line, and then eventually how the stars kind of have a life cycle. They form from gas, and then they create gas again, and then back and around. So those if you're interested in that, you probably want to mostly look at Unit 6, and then maybe a little bit further as well.
One thing that really caught my attention as well with your all the units is that, well, they're available in both English and French, which is great for schools. If some of you teach in French immersion schools, everything's there. It's
Yeah.
perfect.
Yeah, both are freely available. Yeah, now that I'm sort of just riffing here and looking through this myself, we to those discussion and review questions that we have, we actually provide some answers or just suggested ones, because they are mostly open-ended questions. So we kind of talk about that a bit in this document here. As well as we provide a quick little introduction separate from the different units on Stellarium itself. Just very simple. So that's all there. And I'm sure Julie
Awesome.
put it in the chat, but this is all right now accessible, centeroftheuniverse.org /exo explorations.
Yes, I did put it in the chat. Do you want to mention quickly, because people might be confused, why is it called Center of the Universe, but you're the Friends of the Dominion Astrophysical Observatory? Just want to mention that quickly, and maybe the other programs you offer for teachers.
No, that's excellent. Yeah, I thank you for telling me to do that, because I'm understand that could be confusing. We are the Friends of the Dominion Astrophysical Observatory. So that is the nonprofit and education and outreach side of the Dominion Astrophysical Observatory, which is an observatory that is run by the National Research Council of Canada. So that's all government doing research. And then we're the nonprofit that does the education and outreach and community outreach that sort of works with them. And so the Center of the Universe is the actual name of the building. It's like a center for learning about the universe that's next to the observatory. So that is a literal place that we named. And so in normal times, we would actually have students and just the public come up to and see our gallery and museum and presentations, and to see the telescope itself as well. And then Exo Explorations is just one project that we've been working on. There's plenty of different things we do. We do school tours. Now they're online school tours. So just like pretty much a Zoom call with myself and Lori Roche and Sid as well. We all get into a Zoom call with a classroom, and then we talk about a topic that they're interested in that's astronomy or science related. And we also do our absolute best to show what the observatory looks like, although we don't have easy access to the telescope all the time, but we do have pictures, and we have some things in our gallery to show to make it a little bit more, feel a little bit more like we're stepping into the classroom, or they're stepping into the museum. what else do we do? Oh yeah, Canyas. Canyas is interesting. It is similar to the school tours, except we actually invite a astronomer that's actually working, studying, or operating a telescope or something to just talk about astronomy, the topic that they work on, as well as just talking about what it's like to be an astronomer, which is, I think, a great resource for the kinds of students looking into career, so maybe the high school level and stuff, but also plenty of like elementary school have done Canyas as well. And then we also have things that are less school related, like our Saturday night star parties, which again are now online, where it's like a Zoom call where we invite a presenter to talk about their presentation. And that's more for like a all ages kind of event.
Awesome, thanks. I do, oh, I just see it. If you have questions, I guess this would be a good time. Hold on, I'm gonna change the setup a little bit. So there we go. So I don't, it's just, I'm not just a voice in the background, but people can actually see me talk. Thank you for mentioning all that. Of course, I knew myself about the center of the universe. I used to work there. So that's why I said like this, the observatory was really close to my heart because I worked there for a few years. But I think I really like your exo explorations. I think this is a great resource. And the fact that you go step by step, that was a comment actually that came in the chat. Like these are good instructions step by step. So thank you for going through one unit. And with Stellarium, that was wonderful actually. I don't know if some of you that are live already knew about Stellarium. I put the links there to download it or use the web version. Or maybe this is something, Calvin, are you familiar with the web version?
I'm just barely familiar. I'm familiar
Okay.
enough with it to know that it's not nearly as feature complete as the downloaded one. Of course, not everyone can download the installer onto their computer. If they need the convenience, it just can run in the browser, but it does lack a lot of the features that that we kind of go into in exo explorations.
Exactly. It's a great backup if you can't install it, but I think you're right. It would be hard to follow your unit with the web version. But yeah, it's a great tool. I use it and I recommend it all the time. So if you're not familiar with it, then hopefully this was a great introduction to how to use it. It has actually, I even learned a few things. I have never tried the owl view in Stellarium before, so that's great. I'm learning things too. I know many of you are still online. So if you have questions, go ahead. But otherwise, I think we'll wrap up here. And hopefully that was a good intro. Go check their website and check out the different units. And Calvin, I believe you're available. Like I think on all units, they see
Oh
your
yeah.
email address.
Yeah, we try to make it abundantly clear that I'm open to people to contact me through schools@centeroftheuniverse.org, to either ask about our like school tours and things, but then also any feedback you have for exo explorations. I'd absolutely love to know how you implement it, if you're just using it as a resource yourself, or you're actually pulling on some of those activities and actually deploying them in the classroom, or using it in some creative way. I'd like to be aware to know how to change it or make it better for sure.
Definitely. We do see a question there. Maybe they're wondering, like, do you get a lot of demand for tours? Because, sometimes you feel bad asking if, they're already overbooked. So is there room for more? Like, can people contact you for tours?
There's definitely room for more. Yeah, it just it's, as I guess with scheduling anything, sometimes it's like we have so much open room, and then sometimes we have just like room, but like months from now or something. But like, yeah, right now it's good if you just don't hesitate to ask.
And actually, Lori, thank you for answering the chat at the same time just before. Oh, and she already answered, but just repeat it here. People don't see the chat, and I believe the recording will have it. Can schools from other provinces take tours?
Oh yeah. In fact, I kind of encourage that. I do want to make this to be a bit more than just British Columbia. I like that to be a bit just all of Canada.
Yeah, this is something I really like, because even though you link to the BC curriculum, I mean, it's the subjects, and this is something we see all the time with Discover the Universe. It's like the same subjects come up at, if it's not exactly the same grade level, it's pretty close. We usually start by, like the stars and then solar system and Earth, Moon. We don't go into black holes right away in grade 3 usually. So even
Yeah.
though kids are interested, but so
Um,
it's easily transferable to other provinces, their
exactly.
content. Yeah.
The grade 6 science BC curriculum was just a strategic starting point for us to actually get the ideas laid out. And then that alone can be, like you said, employed anywhere else. But then we also plan to eventually like fill that out with different grades, or if curricula are a little bit different around, then we'll change it up.
Oh, we got a great question here. I'm guessing we have a participant. It's probably very late for you, Marina. Can schools from Greece
Yeah.
can schools from Greece take tours?
Fascinating. I hope so. I think so. Lori's in the chat. She can be a bit more of a decider on that, but I would love to do that.
It's that's a great thing with so many things being online now. I guess there's some downside, but the good thing is that you can reach people
Yeah.
all across the world.
Yeah, the time zone will be will be
A
interesting to
challenge.
schedule, but yeah, but I mean, like, I'm in astronomy. I'm used to being up in odd hours anyway.
And yes, the Marina, she's joining us. It's 2 a.m. over there. So thank you for joining us so late for you.
Yeah.
Um, this is awesome. Thank you very much, Calvin, for accepting my invitation to come and show everyone, the great resources you're developing. So thanks to those of you who could join us live. I know many of you will be watching the recording. So if you made it this far in the recording, thanks a lot for staying with us till the end.
Yeah.
And I think we'll end here. I will stop the recording here, and then if the last few people have a few questions, maybe Calvin can take them. But I
Great.
just wanted to thank you again.
Thank you. Appreciate it.